We're going to go ahead and take a look at Rolle's theorem and the mean value theorem. As we look over here, is there any way if you were sailing from point P to point C or Q, is there any way to be able to go from P to Q in which you would not be going in the direction of a straight line? Well, the slope of your straight line here, you know, is your average rate of change. It's the slope between any 2 points. As you look here on this graph, we really have two instances where we are at that same slope instantaneously. One right here and one right up here. So in this case, there are two positions where we are at that same slope. Now, do you have to have two? No, it is possible you could have been going from here and then come up here. And then in that case, there would only be one right here where you were sailing in the same direction. So at some point when you're going from P to Q, you have to be sailing in the same direction of the straight line distance or direction. That's for the most part what the mean value theorem is saying. It basically says if you look at the average rate of change between any 2 points, which is just the slope of your line, somewhere in between these 2 points, there has to be an instantaneous rate of change. The slope of your tangent line would have to be the same value as the slope between the two. So basically it's saying your derivative has to be equal to your average rate of change at some point between your a and your b. That works as long as your function is differentiable on all those points. Now, to be able to go from this one right here down to what we have below here, all they're doing is taking your blank equation up here and multiplying both sides by your common denominator. So, as we look here, we're going to look at a specific situation for Rolle's theorem. Rolle's theorem takes what we were talking about with the mean value theorem to another extreme. Basically, it says if you have 2 points that are at the same height, at some point in between those two, you're going to have a maximum or a minimum, meaning the slope of your tangent line would be 0. Because when you're looking at this, if you're looking at your average rate of change between these 2 points, it's a horizontal line, and you should remember the slope of a horizontal line is 0. And so we're saying your average rate of change is 0 when they're at the same height. So we're saying at some point your instantaneous rate of change between those 2 points has to then be equal to your 0. And that's what we're saying here. And once again, that's on a continuous indifferentiable function. Now, that is not the case over here on the far right, because at this top point, we have a cusp. And you should remember at a cusp, it is not differentiable. Your derivative does not exist. So you cannot apply Rolle's theorem to the right-hand situation because it is not differentiable on the whole interval. Well, we're going to start off here and we're going to apply Rolle's theorem. First of all, we need to find where it's at the same height. Here it's saying let's go ahead and find the zeros. And if you find your zeros, you know your zeros are where you're crossing your x-axis. And so therefore you would know you'd be at the same height. To find your zeros, you want to set your function equal to 0 and solve it. So if you set your function equal to 0, you might as well go ahead and pull out your common factor. You now have two things multiplied together to give you 0, so the first thing has to be 0, or the second thing has to be 0. So you get the two zeros of your function to be 0 and 1. So Rolle's theorem then says somewhere in between your 0 and your 1, your graph would have to have a horizontal tangent, meaning your derivative would be equal to 0, somewhere between 0 and 1. Well, let's go ahead and take your derivative then. And Rolle's theorem says we need to then take our derivative and set it equal to 0. So all we have to do then is just go ahead and solve this. Now, you'll notice you have a couple of terms here. So let's just pull out that common factor that we have. Let's pull out the half. Let's pull out our x to the negative 1/2, because remember, you always want to pull out the negative or the smaller exponent. So in front of the minus sign that we have here, we'd only be left with a 1 when we pull that out. After your minus sign, the over 2 is gone, so you're going to be left with a 3. Then you're going to be left with an x just to the first power. Well, if you wanted, you could think of this then as a 1 minus a 3x over the 2 root x, and you're having that set equal to 0. Well, when you set that equal to 0, the only time a fraction is equal to 0 is when the top is 0. Solve the top, and you get x to be 1/3. Well, Rolle's theorem says where our derivative is equal to 0 has to occur between our points of equal height. In that case, it was when x was 0 and x was 1. Is our 1/3 somewhere in between our 0 and 1? Yes. And so our answer is 1/3. Well, here we need to apply the mean value theorem. So basically, you want to go ahead and find your average rate of change. And this is your x being 1, x being 4. So you plug in 1 and 4 for your x's. So you're finding your average rate of change, your slope here. Plug 4 into your function, plug 1 into your function. And so then your average rate of change is 1. So that's the right side. Over here, you need to deal with your derivative. So you take your derivative of your original function, and you get this. So that's our derivative, 4 over x squared. So the mean value theorem says that derivative has to be equal to your average rate of change. So we'll set them equal, and then we'll solve. Our derivative equal our average rate of change, our slope. Multiply both sides by x squared. Solve it, we get plus or minus 2. But keep in mind, we were going between 1 and 4. So our only answer here is going to be the positive 2, because our negative 2 is not in that interval. Here we have the mean value theorem in regard to road trip. You have 2 toll stations, 70 miles apart. You drive it in exactly 1 hour. Therefore, your average speed was 70 miles an hour. At some point then, if the posted speed limit was 65, they're concluding that at some point you would have had to have been going above 65 to get an average speed of 70. So they're applying the mean value theorem here, and then they're issuing speeding tickets. Now, the Pennsylvania State Police are not necessarily the only ones that do that, but this is an example.